Hello learners, welcome. Form 3, we were dealing with topic 2. We were dealing with the empirical formula. We were lesson 4. We have done example 1 to example 5. Number 6 today, the question reads like this. When a hydrocarbon was completely burned in oxygen, 4.2 grams of carbon dioxide and 1.71 grams of water were formed. Determine the empirical formula of the hydrocarbon. So we are given bracket, carbon is equal to 12, we are told oxygen is equal to 16, and we are given hydrogen is equal to 1. So in this question, it's different from the other one, but as usual, we are going to use the same procedure that we have used to determine the empirical formula. The first one, we are supposed to write elements. So we are going to write elements. So our reacting elements in this question will be 2, because we are told hydrocarbon. So hydrocarbon consists of carbon and hydrogen atom only. Hydrogen. So these are our, first of all, elements. Then let's see their symbols. So carbon is written C, hydrogen is written H. The next here, if you check, they have given us masses of the product. So we are going to start, first of all, mass. Okay, how are we going to get mass? Let's read the question again. When a hydrocarbon was completely burned in oxygen, 4.2 grams of carbon dioxide. So how do you write carbon dioxide? CO2. Here we want the mass of carbon. So we can get the mass of carbon from carbon dioxide. So how many carbon do you have in carbon dioxide? That's 1. So what is the relative atomic mass of carbon? That's 12. So we say 12 over the total mass. That means the RFM, the relative formula mass, or the relative molecular mass of carbon dioxide. Carbon is 12, but as 16 of oxygen times 2, that's 32. So 12 plus 32 will give me 44. So it will be 12 over 44 times the mass of carbon dioxide given, which is 4.2. So here, the mass of carbon that I am going to get will be 1.145 grams. Okay. We go again, do the same in the side of hydrogen. Where will you get hydrogen? We are told, and 1.71 grams of water were formed. So how do you write water? H2O. So here is where we are going to get hydrogen. So how many hydrogen do you have? 2. What is the relative atomic mass of hydrogen? 1. So it will be 2 times 1, which is 2, divided by the RFM of water. That is 1 times 2, that's 2 plus 16. For oxygen, those will be 18. Times the mass of water given, that's 1.71 gram. So this will give me 0.19 grams of hydrogen. Okay, next, after mass, we were dealing with molar mass. So molar mass. So the molar mass of carbon is given in bracket, that's 12. The one for hydrogen is given in bracket, that's 1. So we are going to have that one there. So after molar mass, we were dealing with moles. So how will you get moles? Moles is given by mass over molar mass. So in this case, 1.145 divided by 12. Here we are going to get 0.095 moles. So here we are having 0.19 as the mass over the molar mass, which is 1. We are going to get 0.19. Thereafter, we are supposed to get the mole ratio. Mole ratio. So how are we going to get the mole ratio? We are going to have, first of all, the moles of that carbon, 0.095, divided by the moles that's less in carbon and hydrogen. So in our case, it is now carbon 0.095. Here I'm going to get 1. Then here I'm going to have the mass of the moles of hydrogen, 0.19, divided by the small moles, which is for carbon, 0.095. Here I'm going to get 2. Okay, then next we are going to get the empirical formula. Empirical formula. So the empirical formula here will be C for carbon, then 1, we don't write 1. Then we're having H for hydrogen, 2. That means CH2 will be the empirical formula for that hydrocarbon. Okay, CH2. So example 7, we are going to go again to see a similar question like the one we have done now. In an experiment, 3.1 grams of a compound of carbon, hydrogen, and oxygen produced 4.4 grams of carbon dioxide, and 2.7 grams of water on complete combustion. Determine the empirical formula of the compound. Let's start first of all elements. So the elements that we are given here are 3. One of them is carbon. We are going to start with carbon. Then the other one was hydrogen. Then the last one was oxygen. So these are the 3 elements that are given. So we are told in an experiment 3.1 grams of carbon compound of carbon, hydrogen, and oxygen produce 4.4 grams of carbon dioxide. So I have here carbon. So how will you write carbon dioxide? CO2. So you get carbon and carbon dioxide, and you have 1 carbon. Let's get first of all symbol. The symbol for carbon is C. The one for hydrogen is H. The one for oxygen is O. Then we go get the mass. Okay. I was saying carbon dioxide is written CO2. So I have 1 carbon. The RM of carbon is 12 divided by the relative formula mass of carbon dioxide, which is 44. That is carbon for 12 plus 32 for oxygen. Those are 44 times 4.4 grams. Because I'm told 4.4 grams of carbon dioxide. So 4.4. Here I'm going to get 1.2 grams of carbon. Then let's go the side of hydrogen. So hydrogen, you get it from water. And in water, we have 2 hydrogen. So it will be 2 over 18. 18 is, we have gotten from 2 of hydrogen plus 16 for oxygen. If you add, it will give you a relative formula mass of 18. So times, okay, the mass for water was 2.7. So here, what are we going to get? We are going to get 0.3 grams. We are going to get 0.3 grams. So let's go next for oxygen. Oxygen can be gotten from both carbon and oxygen. So that means the masses of carbon dioxide and also water, if we used to calculate the mass of oxygen, will give us a wrong answer. But if you check from the question, the start of the question, we are told in an experiment, 3.1 grams of a compound of carbon, hydrogen, and oxygen. And we have gotten the mass of carbon and hydrogen. So we say to get the mass of oxygen, we say the total mass of the compound, which is 3.1, minus, in bracket, 1.2 for carbon, plus 0.3 for that hydrogen. Here, we are going to get 1.6 gram as the mass of oxygen. Okay, thereafter, we are going to get the molar mass. The molar mass for carbon is 12. The one for hydrogen is 1. Then the one for oxygen is 16. Okay, let's get moles. Okay, how will you get moles? Moles is given by mass over molar mass. The mass here for carbon is 1.2 divided by 12. Here you get 0.1. Here you have 0.3 as the mass of hydrogen divided by 1, which is the molar mass of hydrogen. You get 0.3. Here I have 1.6 for the mass of oxygen divided by the molar mass, which is 16. You get still 0.1. Okay, lastly, we are having the mole ratio. Let's get mole ratio. The mole ratio, let's start with this 0.1 and check these 3 values. The one that's having the least moles, it's still 0.1. Here I get 1. So 0.3 divided by 0.1, I get 3. 0.1 divided by 0.1, I get 1. Lastly, I'm supposed to get the empirical formula. So the empirical formula for this compound will be having carbon, which is having 1, we don't write. Then we're having H3, that's hydrogen for 3. Then O1, we don't write 1. So we are having CH3 as the empirical formula for this compound. So next, we're having question number 8. We're having calculate the empirical formula of a compound containing iron 28%, sulfur 24%, and oxygen 48%. And in bracket, we're having Fe, which is 56, S, which is sulfur, 32, and oxygen, which is now 16. Okay, we start first of all, our element again. The element given here are iron, so I'm going to write iron. Then we are given sulfur. Then lastly, we are given oxygen. Okay, the symbol for these elements, we write iron Fe, we write sulfur S, oxygen O. Okay, after the symbol, we are having the percentage composition. percentage composition. For iron is 28, sulfur is 24%, then 48 for the side of oxygen. So next we are supposed to get the molar mass. The molar mass for iron is 56, the one for sulfur is 32, the one for oxygen is 16. Okay, the next I'm supposed to get the moles. How will I get moles? 28 over 56, that's 0.5 moles. Then the other one will be 24 divided by 32. Here I'm going to get 0.75. Then for oxygen it will be 48 divided by 16, it will be 3. Okay, after the moles I'm supposed to get mole ratio. So to get the mole ratio I have to start first of all 0.5, then divided by the least moles, which is still 0.5. I'm going to get 1 there. So here 0.75 divided by 0.5, I'm going to get 1.5. And here lastly here I'm having 3 over 0.5, I'm going to get 6. Okay, so you see here we have in the side of mole ratio 1.5. We cannot round off, so we can multiply everywhere by 2 by 2 by 2. So here I'm going to have 2 for the side of iron as my mole ratio, and 3 in the side of sulfur, and I'm having 12 in the side of oxygen. So to write now the empirical formula, it will be Fe2, then I'm having S3, then I'm having O4. So this can be written Fe2, then here we have 3, so as our common factor, so I can write SO, sorry, here is not 4, it is 12. So here we can have a common factor of 3, so I can take out 3, then I'm supposed to have SO4, then in bracket, then I put the 3 down. That's iron 3 sulfate. So that will be the end of our lesson.